Perfect. This is a site presentation, but it doesn't have to be seen as a site presentation because we work for many sites, so it will be quite a different presentation. So I will present a many sites presentation, I would say. So first of all, let me introduce myself. I'm Oriol. I have a degree in computer science for the Autonomous University of Barcelona. I got a master's also on the Technical University of Catalonia, and this is my Twitter, my GitHub, and I just wanted to say that I learned about EasyBuild in HPCKP, a conference that we organize here, usually in Barcelona, although we eventually did it in Donostia in 2014, a presentation that was done by Jens Timmerman. And I have not used anything else since then. So I'm not going to talk much about HPCNow because I think you might think this is boring. So it will be a short part. So HPCNow is a company created on October 2012. I'm working on there since about 2015. We are now around 15 people. We have more than 50 customers. We've done more than 80 projects. So we have more projects than customers. That means that some customers repeat. So that might be because we are doing good, I hope. And we've done more than 25 EasyBuild deployments. So we've done deployments on the cloud. We've done also the deployments on customers in infrastructure. And later on, I will talk about the challenges that we face while doing EasyBuild deployments. So what we do is we provide installation services for both hardware and software. We do trainings, support, managed service, consultancy, etc. Although we are based in Spain and New Zealand, we have done also projects in Bangladesh, Germany, Mexico, Morocco, and even USA. So let's go to the interesting part. Let's talk about EasyBuild and the challenges and questions that we face when doing an EasyBuild deployment or training. This is why I have added also the questions part. So while doing an EasyBuild deployment, the first question might be, do we have root access to the system? Because if the system is already deployed, it might happen that we do not have root access to the system, which means that we cannot source any file in etc profile.d, and we have to train the users to do something else. So which OS is installed? Can we decide? Sometimes not. It's the system that it's already installed. So we might have to face different operating system, either Red Hat, SUSE, or whatever it's in the customer side. So where can we put the software? We might not be able to decide this because the customer may have their storage already. It might be a filer, it might be a GPFS, it might be a BGFS, it might be an NFS. So although you might think this doesn't have an impact, it has. It really has because, for example, the PERP compilation fails on BGFS. So if you are building and relying on the build path for using a BGFS, there is an open issue because I suppose it's due to hard linking. BGFS does not support hard links, although it supports soft links. The PERP compilation fails. So how many architectures and or microarchitectures do we have? Because we might have systems in which we have, for example, 3 microarchitectures. Are these mixed environment? That means you have it's not it's a single cluster. So I might have to submit to a queue, and my job may end on a Broadwell node or might run on a Haswell node. It's not that I have a single cluster, and sometimes I cannot decide this. It's how the customer built the system. So we have to consider also, will the cluster grow in the future? Which means, will there be new microarchitectures? And regarding the trainings, something that maybe that was discussed yesterday, what about the --robot option? We had some customers that used to do for the installation the --robot option. So as the packets are not aligned, sometimes they ended with an explosion of modules on their systems. For example, many versions of Python, many versions of I don't know, not basic stack, but auto tools, many versions of NetCDF. How do you deal afterwards with this? You have to train them not to use --robots. First, generate the EasyBuild dcconfig file, and then after this dcconfig file is generated, check if I have any of the modules or softwares on the system, and then specify the version that I have. So, and the most important also, where should I put a Python package when I'm installing a Python package? Should I put it in the Python generic module and you skip rebuild? Which means that I will add a new, just a new extension to the system. Shall I create a Python bundle, or shall I add a Python package? What happens if I add it on the Python generic module? If I add it in a Python generic module, and then I create a Python bundle for another package, how can I contribute back if this Python bundle depends on a package I have on my Python package? Because this will fail while contributing, because the Python module at the EasyBuild repository will not have this package. So which packages should go on the Python repository? This is some questions we wanted to raise here. And also, if we have a mixed environment where users can use also pip install for installing packages, if you have a mixed environment and the user does the pip install on their on the Skylake machine, depending on the Python package, it might happen that due to the way EasyBuild works, that compiling for the best architecture you have, you might have a Python package in the user's home which is compiled for the latest architecture, but then when the job goes to Haswell or Broadwell architecture, that job may fail. Instruction not found. So you have to train the users then to modify the compiling flag so that they compile for generic when they compile, when they install packages for themselves, so that they do not crash their production. So sometimes it's even difficult to train the users, to explain them that you cannot do some change because it will affect other users. So with all this in mind, we have come up with this way of working that more or less works for all places. So we define a set of variables. So the software root, that it means the location that we have for installing the software, either NFS, BTFS, GPFS, or whatever. Then we define the OS name and OS version, and then the architecture or microarchitecture specifically. We'll see later on how we define all these variables. We can have this in etc profile.d, or in the case that we do not have root access to the system, we can source this file on the bash RC of the system. So we might come up with those paths. Software/root/CentOS, version Skylake, and then something you have to consider in the case of mixed environments, for example, or in the case of places where that it might software that might not make sense to have replicated everywhere. In case, for example, if you have Haswell, Skylake, or whatever, if you have to install MATLAB, does it make sense to have it on a specific folder? No. So we have also a common folder for things like binaries, like MATLAB, Java packages, etc. That doesn't make any sense to have duplicated for each architecture. So how do we define these variables on this shell script that we've seen? So we usually use lsb release -si, and then we parse the output of this to come up with these names, CentOS, OpenSUSE, because the names might be much longer. For example, for RHEL is Red Hat Enterprise, Linux, all the strings, so it's a bit too long. So for the OS version, we usually rely on lsb release -sr. And this is how we usually get the microarchitecture of the system, by doing the ls grep CPU and grabbing the CPU family and the model, and then converting it to hexadecimal. And talking about this, yesterday we saw the presentation done by Massimiliano. It was that he was talking about they are compiling for AVX, AVX2, AVX 512, but what is AVX 512? I don't know. Yeah. So it might happen also that we realize afterwards that, as you saw previously, we are using the CPU family and the model, but if you check, for example, in the case of Skylake and Cascade Lake, the family and the model are exactly the same. They just changed the stepping. What does this mean? Will I have better performance with this Cascade Lake? If I compile with AVX 512 generic, will I have different results that if I specify MArch Cascade Lake? So this is something that maybe it's not being considered, but compilers usually have instruction scheduling. Depending on the architecture and the changes that they have made on the architecture, they write down the latencies of the different instructions, so that when you compile a software, it decides which is the best instructions to use to make the best use of the pipeline that it can have. So although we do not make any performance testing usually, I mean, we usually now do not compile with different flags and check which is the performance. What if I change this flag with AVX 512 and try with AVX2? Maybe I get better performance by using AVX2 than AVX 512. But is anybody checking nowadays? I don't think so. Talking about yesterday's presentation also, we saw this part of AVX, AVX2, AVX 512 with Zen, also called Naples, and Gen 2 ROM. We do not have new ISAs. The ISA is exactly the same. So should we have AVX2? Because they do not have AVX 512. Or should we compile specifically for Zen and Zen 2? This is why we usually rely on compiling specifically for the microarchitecture. So we also have based compiling for different architectures. So what happens when you switch to a Power 9 machine? If you look for model type, doesn't appear. How do we decide what's important here? As you see, there is no flags listed. So the CPU ID instructions that it's used to get this kind of information seems that it's a privileged information, I think, on power machines and ARM machines. So we cannot rely much on these instructions. So this is all the information we can get. So maybe we can parse this part of the CPU. How does Altivex supported effect or not? With this, we have finally come up with adding here a Power 9 because the system we were working, we didn't know if Power 8 and Power 9 were about to coexist at the same time. So we decided to add Power 9 here so that in case both systems coexisted, they could have their modules. So what about the toolchain? So we have Excel compilers, which have the C++ compiler, XLF for Fortran, but then we have some other libraries, XLSMP, math library, mathematical subsystem, the engineering library, platform MPI. Although we tried to use this toolchain in EasyBuild, it was not working because it was not really maintained. So we couldn't finally use the toolchain. And one of the things that happen if you are working on projects, so that means you have specified the time that you have to do this thing, you cannot, if that becomes too complex and it might be much more time than the time you expected, then you have to switch and finally provide something to the user that it's what needs. So switch to FOSS compilers and forget about this. Will the customer get much better performance with Excel compilers? We don't know. So, and well, just finally to conclude the presentation, I just want to talk about what we usually installed with EasyBuild, that it's NetCDF, OpenFOAM, Word, BioStuff, which means everything from Python packages, from R packages, binaries, whatever. And also what we do not install with EasyBuild, these are mostly binary packages like Abacus, Madimo, PAMCrash, all used in automation companies, which we completely rely on their installation system because it's not worth to invest the time on automating this. And well, that's all. I hope you enjoyed the presentation. And
questions? I have one actually first, or maybe a comment. Should be on. I don't know. It's on here. Hello? Yeah, okay, let's do this one. So I have a bit of a question or a comment. So I did a little bit on this, the example that you mentioned, right? The power toolchain stuff.
yeah.
And it was a pain, right? And actually it was a pain in general with at the time, right? This is a couple of years ago. But at the time as well, because they had that different various Spectrum MPI as well, and all that stuff was only available as an RPM, and even even the CUDA at the time was a pain because they didn't have they only had an RPM install, which was not relocatable, and I mean you could get around it, but it was extremely hacky, right, to try and get it into a tool chain. But it was one of those things that I noticed that if we had the resources, it would be interesting to spend a bit more time trying to get like support for compilers properly and different tool chains and stuff. Because I mean, Spectrum MPI is nothing, right? It's just Open MPI. That's essentially what it is, more or less. With some, I don't know what to tweak exactly, but that's basically it, right? So that would have been easy, but the compiler wasn't there, right? And then the math libraries that they particularly use, and now we see this coming up again, right? With these, with like the AMD systems, they're going to have their own probably variants that they would like you to use with their chips, right? And I guess it's not a question. It's more of a comment. I mean, I see it's an issue, but resources are a problem, right? Nobody else was doing it. Well, maybe you were looking at it when I was looking at it, right? But we actually don't know. I didn't know anyone else was doing it.
The guys from Birmingham will be talking about this.
Yeah. Sorry, any questions or comments from anyone else? Yep.
Hi, thanks for a nice talk.
Thank you.
I saw some things that we also do. So one thing was your build path. We used to do that in DevSmem. Just to make you aware, there are some software packages that don't want to build there, and it's not just because of the size.
Okay.
The second issue is the size. So there are some software packages that you will definitely hit a size limit. And I also saw that your prefixes get quite long, right? Because you make the OS, the version, the microarchitecture, etc., and then whatever prefixes before that. Again, there is some software, Trilinos specifically, that at some point starts to crash when the prefix gets too long. So just to make you aware of that. We have a fix for that. It's sort of a workaround. I mean, it still can get too long in the end if you make it too crazy, but just so you know.
Yeah, thank you.
Oh, and one more thing. We actually did do tests with AVX versus AVX 512 for Skylake Silver nodes, because they do support AVX 512, but they only have one FMA unit for AVX 512, rather than the two that are in the gold CPUs. And for those silver nodes, we found out that it's actually faster to use AVX2 in general, because the clock speed goes down if it needs to do an AVX 512 instruction. And unless you do one AVX 512 instruction after another, which is very unusual for a normal program, you're going to pay.
In this case, it doesn't even make sense to use the -m arch, because it will use the AVX 512 that gives less performance.
Yeah.
I guess you're supporting different architectures on a single cluster, right? You mentioned it briefly. So when a user loads a model and then does maybe Slurm srun, he might not know what kind of architecture he's going to get. Exactly. How did you solve that?
The thing is that in this kind of environments, users usually do not use MPI. So it's not going to affect to the results. So it loads the module and we adapt it. So we have this etc profile.d that has the path specifying where to locate the modules. So that we do not load a module for an architecture that it cannot run. I don't know if I have answered your question.
Yeah, well, when the user does the model load, he might not be on the architecture that he's going to run the code on.
No, we avoid this because we unset all the modules before you jump to the node. Yeah.
And then you reload the user models, or?
Exactly.
The user has to do it in the DOS.
Okay. So you can basically do something we see often, something like srun, Python, do whatever.
And no, they do not usually work this way. They do not do this as srun directly. They usually tend to submit jobs. So they have to specify the module load, etc., and submit the job to the cluster. In case they want to submit something, let's say interactively, they do an salloc, get an allocation, jump to the node, and then load the modules. This is part of the training that we have to do. and explain them what will happen if they do not do it this way.
Okay, but it has a downside that on the interactive way, you got to do the model allocation, the model loading before you jump to the node, because you may want to jump to multiple nodes with srun when you have multiple tasks.
This is why I said that they usually do not use MPI. They won't have this issue.
Okay.
Yeah, I know it's a bit tricky, but it's what we have come up to.
Okay.
This is the important point, that we have to adapt to the specific needs of the environment. Ask the user what they need, how they work, and then provide us solutions for that. The easiest solution would have been to compile everything with the lowest architecture. In that case, I think it was Sandy Bridge, but they have also Skylake nodes.
All right, thanks.
You're welcome.
I guess you kind of have this issue if you have a KNL partition as well, because it's essentially the same thing. It's a different architecture, right? So how do you deal with that? So a couple of different sites do that in different ways. You kind of have no choice, because even in that case, you might want to use both at the same time. It's possible, right? But the user has to do something, right? It's just not that simple.
There's actually tricks you can do to make that more transparent.
Yeah, we have an architecture.
So what some EasyBuild sites do to make this transparent is they install the software in a path that has like Skylake in the path name.
Yeah.
But then they mount this in a generic path where when you actually go do an ls on the file system, you don't see the Skylake in the name anymore. It's just mounted differently based on what kind of system you're on.
Yeah.
And that makes it fully transparent because you're picking up the right binaries on that machine always.
Exactly. But this is why I said at the beginning that we have to rely on the infrastructure and come up with a generic solution that works. Or
you cannot influence the mount points, so you have to come up with something.
Sometimes not.
Yeah.
Well, maybe we can start making mount binds for each of the architectures, so we have the full path and then mount bind.
You could symlink stuff, right?
Also, this is something that we have done on some of the customers. For example, they have a tight budget, so they say, no, I don't want you to spend more time compiling stuff. So just use what I have compiled. So if they get a new architecture, you symlink the path, and for the new architecture, you continue detecting it, but you just symlink the path. But you have to be really careful when you compile that you switch to a node with the oldest architecture, because if not, you can end up with a complete mess.
Okay, let's wrap up, I guess, and switch to Simon for the next talk.